Welcome back. Till now, we were discussing about different scheduling techniques for processes to gain the CPU, and each has different way to get the CPU and get the execution. When it comes to processes, we have different types of processes, and the processes which seems to be user you using, and there are few processes which run all the time. So for that, there should be a mechanism in which both foreground and background will the terms used. Both these kind of processes need to be scheduled. For that, we have the concept of multi-level queue scheduling. Here, instead of having one single method to schedule, instead we have queue of different scheduling which are in different levels of different levels in the operating system. So for different types of processes, another class of scheduling algorithm has been created, that is multi-level queue scheduling. In this, for example, a common division is made between foreground and background processes. What do you mean by foreground process? Which are interactive. Interactive means we are talking to that particular application. What do you mean by background processes? Which are running at the background, your operating system itself. Many drivers are running at the background, and when you're using word, many things which support that particular word are running at the background. All these processes are running at the background. So when we need to understand these types of processes have different response time, because foreground depends on interaction, whereas background depends on the internal events and interrupts. So they may have different scheduling needs, right? Foreground, since uh, the interrupts may cause because of input output or some other things, and whereas background may get affected depending upon the priority, and so on. In addition, foreground processes may have priority over background processes, because in the background they are running, foreground processes are user, so they are given more importance. So that is the reason. So in addition to foreground process, we have background processes with different priorities. A multi-level algorithm partitions, sorry, a multi-level queuing algorithm partitions the ready queue into several separate queue, which can be seen in the figure. See, we have different queues here depending upon the priority from lowest to highest. So every queue has different types of processes, as you can see in the figure. At the lowest priority, student processes. Above that, batch processes, interactive processes, interactive editing processes if you are typing something and all other things. Interactive processes if you are in a time critical or some event driven interactive processes, and system processes which have the highest priority. Without system processes, it is impossible to even think of running other processes. If operating system itself is not running, forget about all these. So these are kept in different levels of the queue. The processes are permanently assigned to one queue, generally based on the property of the process, such as memory size. These are the properties considered to put them in which queue, process priority and process type and all other things. So each queue has its own scheduling algorithm. Here we have different 1, 2, 3, 4, 5, 5 different queues. Every queue has its own algorithm to access, right? So system process, they all related to system processes are put in this queue, all related to interactive processes are kept in this. And every queue has their own way of execution. For example, this may follow first come first serve, or this may follow This may follow priority scheduling, this may follow round robin, and so on. It depends on the operating system which this particular queue follows. So, for example, separate queue might be used to foreground and background queues. The foreground queue might be using a round robin, which I have told, while the background queues might be using first come first, or whichever comes first will be given the uh, process. There must be scheduling among the queues itself, which is commonly implemented by fixed priority preemptive scheduling. For example, foreground queues may have absolute priority over background queue. If any background is running, if you have gotten a foreground process, it has to make the way for background foreground process. So let's look at the example how this works. This is divided into 5 different process queues, which starts from the system processes and this student process queue from the point of priority. So each queue has absolute priority over lower queue. So as we have seen in the, this has absolute priority over this. So if any process comes here, CPU will be given importance to this particular process, not this. So this is how the lower priority always has absolute uh, priority over the lower one. No process in the batch queue, for example, could run unless the queue for the system processes, interactive processes, and interactive editing processes will be empty, where other will start executing. If an interactive editing process entered the ready queue, which while a batch process is running, then batch processing would be preempted. So we need to understand the lower priority system processes are preempted to give priority to give CPU to the higher priority processes. Another possibility is time slice also. If you are running, if you are using round robin, time slice. So hence, each queue gets a certain portion of CPU time, which can then be scheduled among its various processes. This is how um, multi-level queue executes. Let's see an animation related to this multi-level queue, which helps us to understand this particular concept more.
Foreground. Multi-level queue. MLQ. What is multi-level queue? Oh my god. Multi-level queue scheduling happen in the ready processes, which can be divided into 2 different classes. Foreground. Background. These 2 classes have different scheduling needs. For this kind of situation, multi-level queue scheduling is used. Ready queue is divided into separate queues for each class of processes. Now, let us see how it works. Now let's see how the CPU process scheduling. In this algorithm, the processes are grouped accordingly to their types. Once the queue is ready, it is then divided into several small queues. Then, the group of processors is placed into each group. It is labeled highest priority and the lowest priority, which means the upper level queue has a higher priority than the lowest level. Then, each small queue is labeled with P1, P2, P3, P4, P5, P6, P7, and P8. If suddenly, P3 queue is not available anymore, the processes cannot change their queues and their places during the lifetimes. But the other queue will still works, so the P2 will works after the P1 work finished. Same goes here, the P5 will begin works after the P4 is finished work, and then the P6 will begin to work after the P5 finished work. There might use each one of the CPU scheduling algorithm in each queues. So, here we use FCFS, RR, SJF, and priority. So here, FCFS represent first come, first serve. RR represent round robin, and SJF represent shortest job first. And we do have priority. By the way, what is the advantage of using multi-level queue? We can apply separate scheduling for various kind of algorithm process, for example, FCFS, SJF, round robin, and priority scheduling. What about the disadvantage of multi-level queue? In multi-level queue scheduling, the main disadvantage is the starvation problem for lowest level process. Lowest priority will wait for the long amount of time because of lower priority or highest priority process taking a large amount of time. This is one of the example of multi-level queue. This is the full explanation of multi-level queue. Thank you for watching.
So, this is how multi-level queue works. I hope you understood the concept.